Hello, everyone. Good evening.
Good evening, ma'am.
Good evening.
Good evening.
Okay. Okay, let's wait for a few more minutes and we will start the session. Fine?
Fine.
Okay. Do you have like any sessions after 8?
Today there is no session. Tomorrow it will be there.
Okay, today is not there. Okay, fine. Okay, shall we start?
Ma'am,
Yeah,
it's a revision session, right?
yeah, it's a revision session.
We don't have any kind of QIQ sessions.
Previous year questions.
Yes, ma'am. Because I think most of the people already done with revision or something.
I think there will be a mock test, sorry, mock revision session, I think.
Okay.
Tomorrow. Yeah, tomorrow or day after tomorrow.
Is he going to take some questions or just theory?
When
Of
today?
yes.
Today I would be giving you the summary of week 9 and week 10, and we would be solving some questions. That's it.
Okay.
Yeah. You are done with the revision.
Yes, ma'am. I revised entire syllabus, but actually, I don't have any kind of papers to solve. I just saw one video on YouTube, and it's like 1 year ago on IT Madras BS channel. But so that's why I say now, matlab, if UIQ session are possible, then please try. Uh,
Previous year questions. Mhm. Yeah, okay. Let me just give you the summary and all, and we will just solve some of the questions and let's see, like from the previous year. Let's see. Okay.
okay, ma'am.
There are some, yeah, like one or two questions are there from the previous year questions. We will solve it. Okay.
Okay, ma'am.
Okay. Okay. So now, shall we start now?
Yeah, please.
Okay.
Yes,
So in
ma'am.
week 9, we have 4 topics. Which are the 4 topics? Which is random variable, discrete and continuous. Then we have the PMF and we have the CDF. Okay. So now, what do you mean by random variable? Anyone?
Function defined from simple space to some sort of real number.
Yeah, correct. Like if I'm having, like for example, let's say I'm tossing a coin 3 times. Okay. So my sample space would be triple H, okay, HHT, then something like that till TT. Okay, this is my sample space. So I'm considering my I want to I have to consider the probabilities like the number of heads that appear. Okay, so I will be denoting a random variable X, which is denoting the number of heads which is appearing in during the tossing of coin. So this is a random variable which is describing one outcome. Okay, now with respect to this, what are the number of what are the outcomes that we will be having? It would be like what are the values that it can take?
0, 1, 2, 3.
0, 1, 2, and 3. And with respect to these values, we can have the probabilities associated with it, right? So for 0, what is the probability?
1 by 8.
1 by 2 into 1 by 2 into 1 by 2.
Hmm?
Yeah, yes, ma'am. 1 by 8. Yeah, correct.
1 by 8. Then for 1,
So 3 by 8.
3/8.
3 by 8. For 2,
So 3 by 8 again.
3/8.
3 by 8. Then
1 by 8.
1 by 8. Is it clear? So with respect to the values of random variable, we can associate a respective probabilities as well. Is the probabilities clear to everyone?
Yes.
Yes, ma'am.
Is it fine? Okay. Now, in random variable, we have 2 kinds of that. Okay. The first one is discrete and the second one is continuous. So what is a discrete and continuous random variable? Anyone? Okay. What is discrete random variable?
A random variable that take values in kind of jump or something. Like
Where you can
Countable.
No,
countable quantities.
countable values are discrete.
Within
Countable.
an interval.
Yeah, which is a countable number of possible values, which can take countable number of possible values. Okay. And what is continuous random variable?
They are in intervals.
Yeah, there are in intervals. Correct.
And
And they are not.
for continuous, one of it is
They are
like a
not
timing.
countable.
Supposing the flight is coming between 4 and 6, and if they say that what is the probability that it will come exactly at 5, it will be 0, right?
Hmm,
Because for a particular thing, it will not be available, na?
correct.
It is equal between
So,
intervals.
yeah, these are intervals. So in like if you have to discriminate between the discrete and continuous random variable, you just have to make sure like if any if any number is having any measurements, okay, like its height, like it's in meter or centimeter, it's in kg or in liters or in like if it's having any measurement scale, then it is a continuous random variable. Other than that, it is a discrete random variable. Like if it's in countable form, then it's discrete, and otherwise it is a continuous random variable. Okay, like for example, just tell me if I'm like the temperature of a person. If is it a continuous or a
Yeah,
discrete
yes.
random variable? Sorry,
Continuous.
it's a continuous, right? And
Continuous.
yeah, and the number of accidents in a day,
Discrete.
Discrete.
it's a
Discrete.
discrete, right? So
Discrete.
if there is any like if there is a height, if there is temperature, if there is speed, so they have measurements, right? There is like kilometer per hour, like feet, inches, and all. So there are measurements. So that's a continuous random variable. Okay, and discrete is like we can count it. Fine.
Ma'am, can you please explain once more?
Which one?
The discrete.
Okay, discrete is like you can count it, like the number of persons, number of accidents, anything that you can count. Like we have discrete values, we can count it. That's a discrete random variable. You got it?
No, ma'am. Can you please be more specific?
Specific, like,
Ma'am, can you please give an example? Just take a case about something and then explain it.
okay. Let's say, mm, like if I'm having a table, mm, just a second. Like if I'm having like a table in which I like it's a table of apartments. Okay, so I'm having like let's say I have 4 floors. Okay, and in each floor I have 1 BHK, 2 BHK, and 3 BHKs. Okay, now I have like in 4 floors I have 1, 2, and 3. Similarly, I will go, this is for 1, 1. This is the first floor. Okay, these are the number of floors. These are the number of floors. This is the, mm, you can say the BHK. Okay, so for first floor, we have 1 room set, we have 2 room set, and 3 room set. Similarly, for the second floor as well, and for the third. Similarly, we can go and like this. Okay, now how many number of like if I count like here the number of bedrooms. Okay, so I'm having 1 bedroom here, 2 bedroom here, 3 bedroom here. Similarly, for the second floor, 1 bedroom, 2 bedroom, and 3. So I have made a table like that. Okay, now I'm writing here the, let's say the size of the apartment. Okay, now some of the values are like 900.83 square feet. Okay, this is like let's say 1000.23. These are all in square feet. So I would be having some numbers here. Okay, so if you look here, we have a discrete values, right? 1, 2, 3, 1, 2, 3. These are countable, right? So this would be a discrete random variable. And here we can't like count the values. Like the size are between some intervals, right? It can be between 900 to, let's say, like there are some values till 2000. Okay, so we can't have any particular countable values, but we can have the values in interval. So that's why this is a continuous random variable. Now you got some idea?
Excuse me, ma'am.
Yes, ma'am. Yes, ma'am.
Hmm.
Excuse me, ma'am.
Yes, yes.
Ma'am, can a random variable take negative values?
Yeah, it can take any, yeah, it can take negative values as well.
Ma'am, can we simply say that discrete variables are all integers?
Hmm. Correct.
Okay, ma'am.
Now you got now you got what is discrete and what is continuous. You can differentiate it now.
Yes,
Yes,
ma'am.
ma'am.
Okay. Now the third topic is PMF. Okay,
Excuse
which
me,
is the
ma'am.
pro
Can you please repeat the I am late join?
See, I just told like I told what is random variable. What is a random variable if I'm having a sample space? Okay, and if I know I want to know the outcomes of number of heads. So I'm denoting X as a random variable, which is denoting the number of heads. Okay, and it can take value 0, 1, 2, 3, and associated with we can have respective probabilities as well. Okay, and random variable are of 2 types, discrete and continuous. Discrete are random variable which are countable, and continuous are the values which are in intervals and cannot be counted. Okay, so
What is
if
the countable means?
countable which can be counted like 1, 2, 3, 0, 1, 2, like discrete
Okay,
values. Yeah, and continuous is which are in intervals. Okay, so for example, this is my example, right? We have a table in which we have floors, we have the rooms, we have the number of bedrooms, and we have the size of the apartment. So here we have the discrete values, right? 1, 2, 3, 1, 2, like these are the values that it can take. So we can count it. But the size of the apartment, we have the intervals, right? So it's like 900.83 square feet, then 1,000 to 2,3. So we cannot count it. So we are having the size of the apartment as in intervals. So that's why this is the continuous random variable. So any numbers which is having any measurement scale, it is a continuous random variable. Fine. This was the thing that we have done till now.
Okay, ma'am. Thank you.
Okay. Okay. Now, what is a PMF? Like we have like x, like let's say x is a discrete random variable, and it can take values x1, x2, x3 till xn. Okay, these are the values. Like in the previous example, we have values of x as 0, 1, 2, 3. So this value is x1, this is x2, this is x3, and this is x4. Okay, and we have also said that with respect to these values, we can associate a probabilities. That is probability of x equals to xi, right? So we can say that. So what is a PMF? That the probability associated with each random variable is the PMF for a discrete random variable. Okay.
It is for
So
each variable, not the sum, right? That is only its property. It should be
yeah, for the x1 value, the probability will be px1. For x2, it will be px2. So for each random variable, we have respective probabilities, which is called the PMF. Okay.
probability of each variable is its PMF.
Yeah, correct.
So what's the full form of PMF, ma'am?
Probability mass function.
Okay, ma'am, thank you.
Okay. So in earlier case, we had the probabilities like it was 1/8, 3/8, 3/8, and 1/8, right? So this is the probabilities for x1. This is the probability of x2. This is the probability of x3, and this is the probability of x4. So with respect to the values, x1, we have the respective probabilities. Okay, so this is the PMF, you can say. These values are the PMF. Okay. Now, there is one property. There are two properties that satisfy the PMF, that it's a correct PMF. Okay. So the first property is what?
It should be greater than 0.
P of xi should
yeah.
be greater than 0.
It should be greater than equal to 0. And the second property is
Sum should be equal to 1.
Summation should be 1.
it should be equal to 1. Correct. So let's take an example. So if I'm having values of x as, let's say 1, 2, 3, 4, 5, and we have the probabilities here as well, which is like 0.4, 0.1, 0.2, 0.1, and 0.3. So I have to check whether it's a correct PMF or not. So the first property is I'm going to check if my all the probabilities are greater than equal to 0. So if we see here, all the values are greater than 0. So my first property is correct. Now the second
Yes.
property is my summation should be the sum of all the probability should be equal to 1. So let's add all these values and check whether it is coming to be 1 or not. So tell me if it's coming to be 1.
No, it's not coming.
It's not coming to be 1. That means this is not a
It's coming
correct.
1.1.
Yeah, so it's not a correct PMF. Similarly, if I say, if I'm having the values, like this is the same values I'm having, okay, 1, 2, 3, 4, 5, and the probabilities are different this time. Okay, so this is 0.3, then 0.1, 0.2, 0.4, and 0. So tell me if it's a correct PMF or not.
Yes,
Is the
ma'am, now
first
it's the
property,
correct PMF.
yeah,
Yes,
because
it
the
is
first
correct.
property is getting satisfied, right? And the second property, that the summation should be equal to 1 and it's coming out to be 1. So that means this PMF is the correct PMF. Okay.
Yes, ma'am.
Yes, ma'am.
So this is these are the two conditions that you have to check whether it's a correct PMF or not. Now, we can also graphically represent this, right? We can graphically represent our
Excuse me,
PMF.
ma'am.
Yes.
Ma'am, can you tell that P of I is equal to C lambda raised to I upon I factorial, that one?
Oh, okay, that one. Just a second.
That is one point.
But that's not that important, but okay, if you want, I
The
can tell.
constant one.
Yeah, the constant one. Got it. Let me check it once. Okay. It is just an example, right? So suppose X is a random variable which will be taking values. Okay. So it's just like it's an example. See, X is a random variable which is taking 0, 1, 2. Like somewhat this probability is still infinite. There are infinite values, and the probability associated with it is C lambda I raised to lambda raised to the power I upon I factorial. Okay, so this is the probability associated with each values. Okay, so probability of 0 is this, probability of 1 is also this. So the probability is same. So we have to calculate the value of C here. Okay, so we know that the second property, that the summation of the probabilities is equal to 1. That means summation of C lambda I upon factorial I is equal to 1. I is going from 0 to infinite. Okay,
Yes.
now, so summation is for the I. Okay, so I'm taking C out of the summation. So it would be I goes to 0, lambda I upon factorial I equals to 1. Now we know that like exponential raised to the power some value. It is equal to summation of xi upon factorial I. Okay, so now this value I can write it as C e raised to the power lambda. This value, if I just
Yes.
compare it with this. Okay, in place of x, I have lambda here. So I would be having lambda here only. So it would be C e raised to the power lambda equals to 1. Okay, so now C
Yes.
would be equal to 1 by E lambda. I can write it as e raised to the power minus lambda. So my value of C is
E raised to
e raised
minus
to the
lambda.
power minus lambda. That's it. It's just an example to find out the value of C.
Okay, ma'am.
Okay, now it's clear?
Yes.
Okay. So can we continue now?
Madam, what is the use case of this?
Which case?
What is the use of this particular way it is put into use? Can you put any
Yeah,
example?
if you like, if you get any question like you have been given the values, like okay, you have been given the different values, and with respect to it, the you have been given the probabilities. Okay, and one of the probability is like it is given as k. Now you have to find out this value. So how will you find out? You will find out by this by using the second property, which is summation of pxi equals to 1. Then you will be adding all the probabilities, putting it equal to 1, and then solving the case. Then you will be finding out the value of k. It's just an example to how
No,
to
that is okay. That is okay. I'm talking
yeah.
about the lambda one. I'm talking about the lambda. E raised to minus lambda, which you have given.
Yeah.
How any problems on that will come
No, no,
in
no.
what fashion?
No, no. It's just an example. That's it.
Okay.
Yeah, it's not that important. Okay, now can we continue?
Yes, yes, please.
Okay. Now we can represent this PMF as graphically as well. Okay. So if I say I have the values of X as 0, 1, and 2 with respective probabilities as, which is like 0.5, 0.25, and 0.5. These are the 0.25. Okay. So I can represent this as a graph as well. So this would be my, so my X axis would be representing the variables, okay, the values which are 0, 1, and 2. And this would be my probabilities, okay? So let's say it's 0.2, 0.4, 0.6. So the value, the probability that is x equals to 0 takes as 0.5. So it would be coming near about to be here. Okay. And for 1, it is 0.25. So it would be coming out to be here. Similarly for the 2 as well. So we can also represent the PMF graphically as well. Okay. Now, like we can have symmetric graphs. We can have positive skewed or negative skewed. We can have uniform as well. So there are different kinds of graphs that we can be getting out of the PMF. Okay. So if I'm having values like, so if my X is taking 1, 2, 3, and 4, and the probability that it takes is 0.4, 0.3, 0.2, and 0.1. So if I make graph of this, so these are the values 1, 2, 3, and 4. So somewhat I would be getting like this 0.4, then 0. Let's see, 3, 2, and 1. So we can see that it's a skewed distribution, right? Positive skewed. So I would be getting graphs like this as well. I would be getting negative skewed as well. I would be getting uniform as well. Okay. So this way you can like graphically represent a PMF. Is it fine?
Ma'am, why it
Yes.
called right squid? Squid something.
Sorry.
Why this graph called right squid?
Positive skewed.
Yeah, why it is positive? Because as the value increases, the y value is decreasing. Then how can it be positive?
See, if you
I'm little confused because in left squid it's like value decreasing, and in right squid I don't know sometimes.
If you remember this graph, like we have the skewness property, right? So if it's symmetric, then we would be having graph like this, right? Like both the side, it would be same,
Right.
Yes, ma'am.
right? Then in negative skewed, we would be having left tail longer than the right tail. That is representing our negative skewed.
And it is called right squid also.
Left skewed.
No, negative squid is called right squid something, right? I saw in professor lectures the people called it right squid. Ma'am, can you just tell me what's the Hindi meaning of this squid? If you can.
Skewness.
What it mean by squid? Yes, SKWED.
Just slant, right?
What?
Just a slant, like slope. That's what it.
Yeah, you can say that.
Maybe it's called
Like,
shift, like it's shifted to that direction.
It's basically a direction of the thing.
like if like skewness is basically to check whether there is a symmetry in the data or not. That's the thing.
Okay, ma'am. So it means like
Like in skewness, like we have values, right? Like in symmetric, the thing is that the mean, the mode, and the median, all the values are same. Okay. In negative skewed, what we have, we say that like this is a picture, so this would be the median, this would be mean, and this would be mode. Okay, so we see that mode is greater than median and median is greater than mean. Similarly, if I'm having positively skewed, that means I'm having the right tail bigger. So that means this is my median. Uh, so like this, I would be having like different values and like the mean, the mode, and the median would be like the bigger. Like in this case, mean would be bigger than median, and median would be bigger than the mode. In the negative, it was the mode was bigger than the median was bigger than the mean. So we have different values. That's why it is a negative skewed, and this is the positive skewed.
Is that measuring from the center origin, negative and positive?
Is it what?
Ma'am, from the axis of y-axis,
Hmm.
ma'am, it is measuring from the y-axis negative and positive.
Y-axis.
Ma'am, left or right of the part of the graph.
Ma'am, here I have got a doubt, ma'am. In the both cases, mode greater than median greater than mean, right, ma'am?
No, 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 no.
Just look at it. I think it's all about x-axis. In negative skewed, mean is less than
Lower
median is.
than, yeah. We have to check for the x-axis.
Okay, ma'am, proceed. We can proceed, I think.
Ma'am, I want to say that it is parted from the y-axis. Ma'am, negative part is left from the right y-axis. Ma'am.
No, 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 no. You're talking about this thing.
Yeah, ma'am.
No, no, no. This is just it's nothing. You can say that.
It means, ma'am, if mode is greater than median or mean, then it is negative. Okay.
Okay. So this is like we have positive skew, we have negatives. It just basically tells us the if there is symmetricity or not. That's it.
Is both the of the graph is in first quadrant?
Yes.
Okay.
How we consider in our current example in this way, skewness?
So if I'm having like this, like in this example, if you see here, this is somewhat like this. Correct? Somewhat. So
Yeah.
this is positively skewed. Okay. If I'm having bars like so it is like correct? Somewhat like this.
So what if mid one is mode?
Which one?
The middle one. Second and
Then it's
third.
uniform. Then it's uniform graph.
Oh, okay.
Ma'am, I have a doubt. Ma'am, I got about the mode and median. Median is the middle value of all the given values, and mode I got the skewed. Like why is it called skewed? Because if a mode is at the right most, like most of the values, like we had a similar graph in evolution, right? If the graph is tilted, then it then shifted to one direction, then it means most of the values are on the right. Therefore, mode is on the right and negative skewed, and median is in the middle. Why mean is on the mean is leftmost? Like in positive skewed, mode is the leftmost. Median stays the same in
For
skewness.
median, we can order the graph first of all for finding median.
Like in skewness, median remains the same at the center, right?
Yeah, always.
Okay, and mode mode is in the direction of the shift.
See, what do you
Because
mean
most
by mode
values are
is
there.
it? Yeah, most values are there. That's why mode
Why
is
mean is on the leftmost in skewness? Matlab, mean is why mean is on the other end. Like, mm, okay, mm,
yeah, I'm not sure about that, but
I think, ma'am, it will be more clear when you take example with Bernoulli trials, where P is greater than 0.5 something, then it will shifted like.
no, but he's
let's
asking.
take your same example 0.4, 0.3, 0.21, 0.2 and 0.1. What's the mean of 0.4, 0.3, 0.2 and 0.1? 43729.25, right? Mean of 0.4, 0.3, 0.2, 0.1 is 0.25, right?
Hmm.
And 0.25 goes to which direction?
How you are calculating the mean of this?
Mean sum of all the values divided by number of values.
No, it
Probability,
would
right?
be these are the probabilities actually. These are not the
Oh,
values.
right, no, right, discrete variable. Oh, yeah.
I think we can calculate EX, like log average mean.
Correct.
I think to calculate mean, we will have to know about for which we are calculating this discrete variable.
I think in right tail, like it actually like it defines that most of the data is present in the right side. Fine. So mean is like we have to calculate the average value. That's why it is coming out to be greater than median. That is on the right side of the median. I think that's the thing.
Maybe it will get clearer after a while.
Hmm.
Ma'am, in the positive case, mode is least, right, ma'am?
Which case?
Positive.
Mode always
Positive.
always greater than everything.
Is it somewhat clear about the skew, like
Yes,
what is
yes, yes.
positive, negative,
Ma'am,
and
in
like?
the symmetry, ma'am, in the symmetric case, all the probability value would be same.
Correct.
Okay, ma'am.
So, ma'am, right skew and positive skew both are same. Sorry, your voice is not clear. Ma'am, right skew and positive skew both are same. Right skewed and positive, yes. Okay, ma'am. Okay, can we continue now? Is this fine? Just remember that if it is in this shape, like the right tail is the most, okay, then it is positive. If we have the left tail bigger, we can say it is a negative skew. That's it. If it's in this shape, this is positive. If this is in this shape, then it's negative. Okay. Sorry, someone asked me about for the symmetric, if the probabilities will be same. It will not be same because the graph would be somewhat like this. So my shape is going to be like this if it's symmetric, right? So I would be having values like this. The graph would be like this. Like that. So this is symmetric. If I'm having the probability same, then I would be having the graph like this, same. All the heights would be same. This would be a uniform distribution, you can say. Uniform graph. Got it?
Yes, ma'am.
Is it clear now?
Yes,
Symmetric,
ma'am.
uniform.
Yes.
Yes.
Yes, ma'am.
Okay. Okay, now. So, can we continue now?
Yeah.
Okay.
Yes,
So
ma'am.
the last topic is the CDF, which is the cumulative distribution function. So, in the PMF, we actually calculated the values of the respective, sorry, we actually calculated the values for the respective variables, right? The probabilities for x equals to 0, for 1 and 2, right? So if I have to calculate the probabilities of x less than 1 or x greater than equal to 1 or x less than equal to 2, then we would be calculating the value of CDF, okay, which is the cumulative distribution function. It is denoted by f a, which is equals to probability of x less than equal to a. Okay, so let's say if I'm having my probabilities are, sorry, my values are 1, 2, 3, 4. My probabilities associated with are 1 by 4, 1 by 2, 1 by 8, and 1 by 8. Okay, so this is my PMF. Now I have to calculate the cumulative distribution function of this, okay, which is the CDF. Okay, so it would be if A. Okay, how would I be calculating? First of all, so like my values are 1, 2, 3, and 4. So for A less than 1, it would be 0 only, correct? For less than 1, this is probability of x equals to 1 is 1 by 4. Okay, probability of x equals to 2 is 1 by 2. Probability of x equals to 3 is 1 by 8, and probability of x equals to 4 is 1 by 8. So these are the values that we have been given. So for a less than 1, okay, it would be 0 only. It won't be taking any values.
Right.
Correct? Now, from 1 to 2, if I make a graph, okay, there's 1, 2, 3, and 4. Okay. And these are some values, like this is 0 0.2, 0 0.4, 0
Ma'am, your
0.6.
voice is a bit low.
Okay, so till 1, it was taking like less than 1, it was having the values as 0, right?
Yes,
So
ma'am.
this now at 1, the value is 1 by 4,
4.
right? So basically it is 0.25, somewhat here,
Yes.
correct?
Yes.
Now till 2, it would be constant, that it would be taking only 0.25, correct?
Yes,
So
ma'am.
from 1 to 2, the value would be 1 by 4 only, correct?
Yes, ma'am.
Everyone, is this clear?
Ma'am, we can also take 1 by 2, right, ma'am? From 1 to 2. P of x equals to 2.
It's
From
less
1
than
to
2.
No, we are taking from less than 2, not equal to 2. It is from 1 to less than 2. It is not equal to 2. Now, in the second case, we are taking equal to 2, less than 3, from 2 to 3. So we see that at 2,
1 by
what will be
8.
the, yeah, it would be 1 by 4 plus 1 by 8, right? So it will be somewhat here, 0.75 something, right? So till from 2 to 3, less than 3, it would be 1 by 8 only. It's not 1 by 8.
3 by 4.
3 by 4. Yeah, you can say that. 3 by 4. Okay.
Yes, ma'am.
You got this value? How
Yes,
we
ma'am.
got?
Yes, ma'am.
Yeah,
1
it
by
is
4
not.
plus 1 by 2.
Okay. Now, from 3 to 4. Now at 3, it would be somewhat here. Okay. That it would be 7 by 8,
Yes, ma'am.
which would be 0.87 something.
Yes, ma'am.
Correct?
0.75.
Yeah. So till 4, it would be taking that value only. Okay. And at 4, it would be having jump.
1.
So this is 1, let's say. So then greater than 4, it would be 1 only.
It should be open bracket now at 0.3 and at 0.4 also.
Ma'am, will you tell the second case, ma'am? 2 less than or equals to a less than 3. 3 by 4.
Which one? This one.
Yes, ma'am.
See, this is the case of when probability of x less than equal to 2. So it would be equal to probability of x.
Yes, ma'am. It is 1 by 2 given.
Yeah, it is 1 by 2. That means we have to add 1 by 4 plus 1 by 2. Correct? We have to calculate like x is less than 2. That means x is equals to 1 and x is equals to 2.
Yeah. Yes, ma'am.
Correct? The probability of x equals to 1 is 1 by 4 and probability of x equals to 2 is 1 by 2.
Yes, ma'am. Okay.
So if you calculate these, we would be getting 3 by 4.
Yes,
Now
ma'am.
you got this?
Yes, ma'am. Thank you.
Yeah. Okay.
Ma'am,
So
in the
if
second,
hmm,
ma'am, in the second case, we have taken x greater than equals to 2, right?
x
3 by 4. X greater than equals to 2 and x less than 3. Am I right?
okay, so this would be sorry, this would be 3. So let's say if this is 3. Okay, so this would be probability of x equals to 1 plus probability of x equals to 2. Now is it
Yes.
fine?
Ma'am, please, can you explain again?
Okay. The whole thing or
No, that less than 3 part.
okay, so we have to calculate the probability that x is taking values less than 3. So it will take value 1 and 2, right?
Yes.
So probability of x equals to 1 plus probability of x equals to 2.
Yes.
So what is the probability of x equals to 1, which is 1 by 4, given here?
Yes, ma'am.
This one. And probability of x equals to 2 is 1 by 2.
1 by 2.
Correct? So we would be adding both of the terms. We would be getting 3 by 4 as the answer.
Yes, ma'am.
That is
Got
for the third case, right? 3 by 4, like 2, in between 2 and 3 when x comes, right?
In between 2 and 3. Yeah. Here.
And I have got another doubt, ma'am. In between 2 and 3, then why should we consider from 1 to 2? Like,
Yes, ma'am.
Because we are like calculating the values
Cumulative.
less than 3. It's a cumulative distribution. We are accumulating the values here.
All the distributions less than 3.
Hmm.
yeah,
But
but
greater than 2 also, na?
yeah.
So 2
See,
3 includes less than 3 and equal to 3 as well. So that's why we are adding with greater than 2 the values, right?
sorry, what?
When
Less
it comes in between 2 and 3,
than?
that includes 3 means 3 equal to the value, what it is? 1 by 4, 1 by 2, right?
Hmm.
And less than 3 also, there are some values which is equal to 1 by 2.
Hmm.
So I
So
think
we
we
are
have to
adding
write
together.
that less than or equal to 3, na? Why greater than 2?
Oh, I think in second case, if we hold a view, 1 is less than 2. Oh, like one is a is less than 1 and a is less than 2. But in second case, you count 2, not 3. And in third case, you count 3 but not 4. And in last case, you count all of and you will get 1, right?
Yes.
Yeah.
So that's in entire case, right? But in case of professor lecture, what ma'am can do, ma'am is taken from 1 is less than, like a is less than 0, less than 1. And there is one more step which is not important at all. But I think it's quite easy and understandable.
Oh, that means we shouldn't consider the lower part, right? 2 less than or equals to a less than 3.
No, here we are not considering the upper part here. We are not including the value 2. It is
Yes, ma'am.
just taking less than 2. That's it. So at point 2, we are having a jump of 3 by 4. Like it is taking value 3 by 4 here. Then till 3, it would be taking that value. Then at 3, it would be having a jump. Okay. Then continuing the same thing. Then at 4, it would be having a jump. Then 1.
So are we taking the jump from 1 or from 2 to 3 like that?
We are taking like when it reaches 2, it is taking a jump here.
Yeah, so overall from 1 to how much jump it will take, that we are considering, right? Why we are adding 1 by 4 plus
1 by 2.
1 by 2. Okay. And in the next case, all 3 jumps we are adding, right?
Correct.
Okay.
And like you said, it's cumulative distributive function. It is more important, like something less than that, just something less than that, not in the range 2 to 3. Just we are calculating everything less than 3,
Yes.
Correct.
not in the ranges. You have written equal to or greater than 2 just to show the steps to add how we are getting that thing. So it's more important to know what is less than 3. So that's why it's 3 by 4.
3 by 4. Correct.
Yes.
Okay. And in some of the like in questions, you would be given the CDF, then you have to calculate the PMF as well. So if you see that this value, this you can say this step is denoting actually the PMF.
Right. The previous graph, the bars graph.
Yeah, this This thing is denoting the PMF. So probability of x equals to 1, we were getting 1 by 4. This is probability of x equals to 2, which is 1 by 2. Okay, so if you just like this value is 1 by 4, right? And this value is 1 by 2. So this this is not,
That one is 3 by 4.
that is 3 by 4, and this is 1 by 4.
4 by
So if
2.
you just subtract it, you will be getting 1 by 2 only. So this is actually the PMF of 2, right?
Yes, so
So this way you can you can get a question in which you have been given the CDF, then you have to calculate the PMF. So you just have to subtract the values. Like for x equals to 1, it is 1 by 4. For x equals to 2, it is 3 by 4 minus 1 by 4, which is 1 by 2. Then for x equals to 3, it would be 7 by 8 minus 3 by 4. Then for x equals to 4, it would be 1 minus 7 by 8. That's it.
yes, ma'am.
Okay. Yeah.
Ma'am,
So,
PMF is for discrete variables and CDF
mhm.
for continuous, right?
Both is for this. Both can
Mm,
be true.
CDF is just a cumulative function. Okay. And PMF is calculated for the discrete. And if it's a continuous, you will be calculating the PDF. Okay.
Okay, ma'am.
Is
What is PDF?
sorry,
What is PDF?
probability distribution function. It is for the continuous random variable.
Ma'am, is there any
You would be
difference?
studying later.
Like
It's a
in
curve, right?
continuous, we study probability density function, right?
Sorry,
Yeah.
probability density function.
Is there any term called PDF, like probability distribution function? Like in professor lecture, I saw some slides where she wrote like PDF.
Yeah, it
Um,
is for the
I
case of
think
continuous random
Can
variable. You will be studying later on, I think, week 11.
12 in week 12 there is a continuous variable system, but uh, sometimes I saw probability distribution function. I was totally confused. Like it's like probability mass system and probability distribution function are same or not. Uh, can you just tell me what it mean by probability distribution function, not density function? Density I'm familiar with. Uh,
we can
ma'am,
use in continuous
Like
continuous
in
functions like
PMF, we have discrete values. So we have like bar graph, columns, and
that we can
PMF,
count.
we have a curve, like continuous curve, no gaps between bars, right? Because it's
PDF.
continuous variable.
I
PDF
know.
is used for which we can't count, like measure, height, weight. We cannot count it
Uh,
by ourselves.
that PDF is probability density, right? I'm talking about
Distributive.
Density.
Yeah, density, sorry.
So
One,
I think
yeah,
there is
one.
only probability density function. There is
But
no
Yes,
ma'am,
yes.
okay, I
probability.
will see some maybe but I saw some name like probability distribution function in slides of lectures. That's why I think I have kind of confused. But it's okay, ma'am. I think we can proceed.
It is for
Prob
uniform
it
distribution.
is, I think it's probability distribution. It is just the probabilities that it is being defined
हो
for
सकता है,
the
ma'am.
like the yeah. Okay. So yeah, this
Hello, ma'am.
was all for the week 9. So
Ma'am, what will be the area under the CDF? We have to find that or not?
under the CDF, which area?
Yes,
Yeah.
sorry, CMF, CDF. हाँ ये.
No, we don't have to find any area.
So a question where he he is asking that what is the area under the CDF? So
I think it would be for the continuous case.
Yeah, it is in continuous.
Area under CDF is always 1 because that's cumulative probability. That is always, if
Distribution.
the
Yeah, the
total
area
area
would be
1.
Okay.
Then
This is
how
for the discrete
the
case.
area in CDF will be 1?
This is for the discrete case. Okay. Is it fine? Like week 9 is clear to everyone? The random variable, discrete, continuous, PMF, CDF.
Yes, ma'am.
Okay.
Yes, ma'am.
Now, anybody said something? Okay. Now we are like in week 10, we have the expectation, we have the variances, and we have the standard deviation. These are the three topics that we have to study. Okay. So what do you mean by expectation? So if let's say if x is my some discrete random variable taking some values x1, x2, x3, and so on till xn, let's say, then and with respective probabilities like px1, px2, like that. Okay. So my expectation, it is represented by E of x, which is summation of x into the probabilities. Okay. I is taking from 1 to n. Okay. It can
It's
be infinite.
basically a mean value of outcome, right?
Yeah, you can say the average value or the mean. So expectation is actually the mean or the average, you can say.
But ma'am, mean has divided by the number of.
That's for the data. This is for the random variable, discrete random variable, which is having some probabilities associated with it.
So
So in that
why
case,
we
we
call
will,
it mean?
sorry,
Why we call it mean?
because we are calculating the average value. This is typically an average value,
It's a long-term average, right? If you
long-term average. Yeah.
form a multiple time experiment, the possibility to get something.
Okay. So this is the formula of expectation of a random variable, which is summation of xi into pxi. Okay. This formula. Is this formula clear? So let's say if my x values are taking, my x values are 1, 2, 3, 4, 5, and 6, and the probabilities associated with are, let's say, 1 by 6, 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 and 1 by 6. And if I have to calculate the expectation, then it would be
21 by 6.
Yeah, so it would be 1, that is summation of xi into pxi, that is summation of this value with respect to the it probability, right? So it would be 1 into 1 by 6 plus 2 into 1 by 6. Similarly, 3 into 1 by 6, there it goes till 6 into 1 by 6. Okay, and we would be getting 3.5 as the answer. Okay, so this is the expectation. Okay, this is how we calculate the expected value. Is it fine? Like everybody is clear with how to calculate the expectation?
Yes, ma'am.
Yes,
Okay,
ma'am.
so let's say if I'm tossing a coin 3 times, okay, and x is a random variable which is counting the number of heads. Okay, same example. Okay, so my x is taking values 0, 1, 2, and 3. Okay, and the probabilities associated was 1 by 8, 3 by 8, 3 by 8, and 1 by 8, right? So if I have to calculate the expectation, it would be 0 into 1 by 8 plus 1 into 3 by 8
How many
plus
points are there?
3. 3 coins are,
Now 0 problem.
sorry, 3 times the coins are tossed.
Oh,
This would be my,
yeah, I
sorry,
got it.
got it? So this would be my expectation. This is the summation of xi into its respective probabilities. So for the value of x1 is 0 into probability of x1 is 1 by 8. So 1 into 3 by 8, 2 into 3 by 8, 3 into 1 by 8. So it would be 3 by 2, which is 1.5. Fine?
Yes.
Okay. And let's say, what is the expectation of a Bernoulli random variable? We know that Bernoulli,
P.
it is P, yeah. So my Bernoulli random variable are taking only two values, 0 and 1. And let's say I'm associating the probabilities for 1, it is P, and for 0, it is 1 minus P. So what will be my expectation? It would be
0 times 1 minus p into
0 into 1 minus P plus
p.
1 into T. So this would be P only. So this is my expectation of a Bernoulli random variable, which is P. Okay. And if we then we have a discrete uniform random variable.
Madam, now the same exercise 0 and 1 which you took. Can you show? Can you go up, please? Yeah. If you flip on the other side, how it will be the average? Can it be P?
Sorry.
If you make P as 0 and 1 as P as 0 and 1 minus P as 1. So can we see that expectation?
No, generally we take in Bernoulli random variable, we generally take the probability of success as P and the probability of failure as 1 minus P only.
Okay, fine.
Yeah. Okay. So if I'm having a discrete uniform random variable, so my x, the values the x are taking is 1, 2 till n. And the probabilities that it would be taking is
1 by n.
1 by n, 1 by n, 1 by n, right? So if I have to calculate the expectation of this value, it would be 1 into 1 by n plus 2 into 1 by n plus n into 1 by n, right? So this would be like 1 by n taking common, so it would be 1 plus 2 plus till n. And sum of n terms is
n
what
plus
is
1 by
n plus 1 by 2, correct? So this would be n plus 1 by 2. So this is the expectation of a discrete uniform random variable. Fine?
yes, ma'am.
Okay. Now we have some properties. Like if I say expectation of ax plus b, this would be equal to expectation, this would be equal to a into expectation of x plus b. Right?
Right.
Correct. And expectation of ax would be equal to a into expectation of x. Okay. And if I'm having, let's say, any random, like a real value function, g. So expectation of a real valued function, it would be summation of gx into probability of x.
Yes, okay.
Okay, so let me give you an example of this. So if my x is taking values -1, 0, and 1, and the probabilities associated with are 0.2, 0.5, and 0.3. Okay, so if I have to calculate the expectation, it is summation of if I have to calculate, so if I'm considering my another function of x, which is gx, which is denoted as y, which is equals to x square. Okay, so if I have to calculate this expectation of y, okay, so this is equal to expectation of gx, which is equals to summation of gx into probability of x equals to xi. Correct?
Yes, ma'am.
Everyone? Is it fine? So gx, what is gx? It is x square, right? So it would be -1 square into 0.2 plus 0 square into 0.5 plus 1 square into 0.3.
Yes, ma'am.
Correct? So this would be equal to 0.2 plus 0.3, which is 0.5.
Ma'am, there is a question. It's like E of ax plus b का whole square ऐसा कुछ.
E of ax plus b whole
Plus
square.
one था वो तो मतलब b की जगह पर.
Ax plus 1 whole square.
Yes, ma'am.
Okay. So इसको बस खोल दो ना. Okay. So this would be a square expectation of x square plus expectation of constant is constant plus 2a into expectation of x.
Ma'am, like let's say we have ax plus 1, so what we can do, first multiply a with like all the multiply a with all the values of x and then add 1, and then we can find expectation by multiplying probability. That's also work.
Huh. But you have to हाँ तो like you will be having a different, this is different function, right? Then you have to square it as well.
हाँ last में. Okay, ठीक.
Okay. Yeah.
Okay, ma'am.
And one important part is expectation of x square is not equal to expectation of x whole square. Okay. This is the most important part. These both are not equal. These are different. Okay. This is where x square, like we have to calculate the expectation of x square. And this is, we are calculating the square of the expectation.
Okay.
Okay. Now we have the fourth
calculating things. First, we are calculating the right hand side. First, we are calculating and then squaring the.
yeah, we are first calculating the expectation, then we are squaring the values. Okay. Now we have the fourth property, which is the sum of two random variables, expectation of sum of two random variable. Okay. So if I'm having two random variable x and y, then expectation of sum of these two random variable would be equal to the individual expectation, sum of their individual expectation. Okay. Okay. So if let's say if x is the these are the outcome of fair die, right? Like we have calculated earlier here. It was coming out to be 3.5, right? This one. Okay. Similarly, I'm having another random variable which is same, which is the outcome of fair die. Okay. So if I have to calculate the expectation of x plus y, it would be equal to expectation of x plus expectation of y, right? And expectation of x was coming out to be 3.5 plus expectation of y was coming out to be 3.5. This would be equal to 7. Okay. You just have to add their individual expectations. Fine.
Ma'am, if both are different also, can we add, ma'am?
Yeah, sure. It's just that like there will be different kinds. Okay. So X would be like outcome of fair die. Y would be the outcome like coming out to be 6 or something. So like that, we would be having different scenarios like random variables for x and y. We can, if we have to calculate the sum of these two expectations, we would be just adding the like individual expectation. That's it. Okay, and we can also extend it to n. Like if we are having n discrete random variables. Okay, so if I'm having x1, x2, xn discrete random variables, then if I have to calculate the expectation of sum of xi, where xi is going from 1 to n, this would be equal to summation of I goes to 1 to n expectation of xi. Is this fine?
Yes, ma'am.
Yes, ma'am.
Everyone?
Ma'am, I have a doubt.
Hmm.
Ma'am, what does expectation practically signifies? How is it like different from probability of an event and expectation of an event?
Probability of an event and expectation of an event.
Matlab, what is the practical significance of
See,
expectation?
expectation is basically a long run average. Okay, so it is like you can say the weighted average of a like you can say the weighted average as well. So if you are tossing like if you are tossing a coin 1,000 times, 100 times, so what is the expectation of getting the number of heads? What is the expectation of getting the number of tails? Okay, so you have, if I have to calculate that, that is my expectation. That is my long run average. Okay.
Okay, yes, ma'am.
Yeah, and
So
probability is like
it seems
probability.
expectation is like a more real world thing. Like
Hmm.
if we want to know about some process or anything, so we are going to calculate expectation.
What is the expectation of like expected like what are we expecting if we would be winning that game or losing that game? So we basically calculate the expectation. What would be my expectation of winning a game or losing a game? That's the thing.
Okay, I got them. Like you said, long-term average.
Hmm.
Thank you.
Okay. Mm, okay. Is the expectation clear? The properties are clear to everyone?
Yes, ma'am.
Okay. Then comes the variance. Okay. Variance is basically, it tells us about the variation or the spread of the values. Okay. See, like if we are calculating the expectation, we are not getting the spread or the variations of the values, right? But if we have to like speak about the variation, we calculate the variance. And the variance is denoted by Vx, which is expectation. What is the formula of variance? X minus mu whole square. And there is another formula which is expectation of x square minus expectation of x whole square.
Ma'am, ma'am, hello.
Hmm.
Before variance, we have to study hypergeometric random variable.
Hypergeometric random variable.
Yes. In the lectures, before
Hmm.
variance, the hypergeometric random variable it comes.
Yeah, it is just in that we are just having the formula of hypergeometric, which is nm divided by 2. That is the expected value of hypergeometric distribution.
Ma'am, when to use this in the practical questions?
When you will be having any hypergeometric distribution, like the case of hypergeometric.
Okay, so they will clarify that the question is hypergeometric.
nm by 2 or nm by n?
Yes, ma'am.
Sorry, nm by
nm
n.
by capital N.
Capital
Capital
N.
N. So the question will clarify that we have to use hypergeometry.
Ma'am, what
It
are
is
the
not, no,
terms N, M, and capital N?
see, in hypergeometric,
Guys, it's week 11, right? So you don't need
yeah,
to worry about that.
it will be cleared tomorrow only, week 11 and week 12.
Yes, ma'am.
Yeah. There you would be studying about the
The
expectation,
session,
the
madam.
variance and all. Hmm?
Tomorrow who is taking the session?
Tomorrow.
And this is in week 10.
This is week 9 and 10, na?
This is in week 10. Hypergeometric is in 10.
Yeah, this is in week 10, but you will be studying more about hypergeometric in week 11 and 12, I guess so.
Yes, ma'am.
Okay, let me tell hypergeometric. It's fine. You don't have any class after 8, right?
No.
Yeah, then it's fine. So hypergeometric, in this case, we are we have to let's say we are having two balls. Okay, one is of let's say red color and one is of blue color. Okay, so let's say we are having m red balls and in total we are having n balls, out of which m are red and how many blue would be there? N minus m, correct?
Yes, ma'am.
Right? Now, if I have to choose n balls from these capital N balls, okay, then we have a hypergeometric situation. Okay, so let's consider if I'm having if I'm having 30 students, okay, in that I'm having 20 boys and 10 girls. Okay, so I am if I have to choose let's say two students. So my n is equals to 2, m is 20, and this is n minus m, and this is my n. Okay. So if I'm n is 2, okay. Now for hypergeometric case, my expectation is equal to n m upon capital M. N is the number of students or the number of ball that we are randomly choosing, okay, and m is the number of balls present, and capital N is the total number of balls. Okay.
Okay.
So if if I have to choose, let's say my x is a random variable, which is denoting the number of boys. Okay, number of boys chosen. So if I have to calculate that expectation, this expectation, that is expectation of x, it would be n into m by n. Okay, so here n is 2 into what is m? M is the number of boys, which is 20, right? So it would be 20 and divided by n. N is 30. So this would be 4 by 3, correct?
Yes, ma'am.
Okay. Similarly, if I'm considering y, another random variable, which is the number of girls chosen. So in that case, my m would be different. N would be 2, my m would be, now in that case, my m would be this, and this would be my n minus n. This would be 10 divided by 30, which is 2 by 3. Got it?
Yes, ma'am.
Okay. So
But
if I have
ma'am,
to
why we use a hypergeometric random variable? We have also Bernoulli random variable. If I let boys are success and girls are failure, I can do this question also with this method.
yeah, but it would be a little lengthy for you.
हाइपरजेमेट्रिक एम्प्लॉइज मतलब हाइपरजेमेट्रिक के लिए तुम्हें आईआईडी होने का जरूरत नहीं है, लाइक बट बर्नौली गोइंग टू फेल ना, मतलब लेट्स से Bernoulli is totally for independence.
Okay. Okay.
And if you and then yeah, so if you have to calculate the expectation of x plus y, so it would be equal to expectation of x plus expectation of y. This would be equal to 4 by 3 plus 2 by 3. This would be equal to 6 by 3, which is 2. So like somebody asked me the values would be like same or not. We can have different values. It's just that we are just adding the expectation of the random variable. That's it. Okay.
Ma'am, by the way, we have class at 8 p.m. ma'am. Maths revision session. Week 5 to 9. You have asked Dana ma'am.
Yeah, but everybody said that there is no class.
No, in Google Calendar just I checked ma'am.
We also have maths 2 class.
Yeah, same here. Maths too.
Nice. Okay, so it's fine. So let's. Okay, so we
Excuse me. Yeah, in this case, we will take only 2 boys, 2 girls like that, or else we can take 1 boy, 1 girl, or 2 like that.
yeah,
Different.
we can have different situation.
So we will be adding the same way we
Hmm.
have done in other
Correct.
cases, right?
Hmm.
Yeah.
Okay, so is this thing clear? Hypergeometric? Okay, now the variance part, the formula of variance is expectation of x square minus expectation of x whole square. So similar, like in the previous example, and that was the fair die, right? So expectation of x was coming out to be 3.5. The outcome of a fair die, the expectation was coming out to be this.
Yes ma'am.
Yeah. So now if I have to calculate the variance of x, it would be expectation of x square minus expectation of x whole square. Correct? So I need the value of expectation of x square. It would be 1 square into 1 by 6 plus 2 square into 1 by 6. Similarly, 6 square into 1 by 6. Is it fine?
Yes, ma'am.
Okay. So like if you calculate this value, it is coming out to be 15.167. So now what will be my variance? It would be expectation of x square minus expectation of x whole square. Okay, so this is 15.167 minus 3.5 whole square, which is coming out to be 2.1917. Is it fine? Like how do we calculate the variances? Like let's take another example, like tossing a 3 point thrice. Okay, so we were having the values like x is denoting the number of head. So these were the values. This were the probabilities, right? It was 1 by 8, 3 by 8, 3 by 8. Our expectation was coming out to be 3 by 2. Now, if I have to, what will be my variance? It would be expectation of x square minus expectation of x whole square. So first of all, I would be calculating expectation of x square. This would be equal to
0 square into 1.
0 square into 1 by 8 plus
1 square into 1 by into 3 by 8.
hmm,
4 into 3 by 8 plus 9 into 3 by 8.
that. So here I'm getting as 3 as the answer. Okay, so my variance would be equal to 3 minus 3 by 2 whole square, correct? Which is equals to 0.75. Is this thing clear? Okay, Now,
From
if I'm
1 by 8, 3 by 8, 3 by 8, and 3 by 8, it's not adding up to 1.
which one?
It should be 2 by 8 and 2 by 8.
This is 1 by 8.
No, 1 by 8, 3 by 8, 3 by 8, 3. Okay.
This is 1 by 8.
Okay.
Okay. Now, for a Bernoulli random variable, what is my variance? It would be equal to
NP 1 minus P. NP times 1 minus P.
no Bernoulli random variable.
Oh,
Ma'am, will you tell the Bernoulli random variable means?
P into 1 minus P.
P minus A also.
Okay, so how did we calculate it? We had two values, 0, 1. The probabilities were 1 minus P and P. Okay, now my variance is expectation of x square minus expectation of x whole square. Okay, so my expectation of x square would be equal to 0 square into 1 minus P plus 1 square into P. Correct? So this would be equal to P only. Now variance of x would be P minus P square. Correct? Now taking out P common, I would be getting 1 minus P remaining. So this is my variance of a Bernoulli random variable. Fine?
Yes, ma'am.
Yeah. Similarly, you can calculate the discrete uniform for the discrete uniform random variable as well. Okay.
Can
So
you
for
please tell one example for this discrete uniform function?
one example.
What situation we will be using this?
So like if I'm tossing a coin, like I'm for the outcome of fair die. So if I have to calculate the variance of that, the outcomes are uniform, right? My x are the values are 1, 2, 3, 4, 5, and 6. And what are the probabilities associated? 1 by 6, 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 right? So if I have to calculate the variance of this, it would be expectation of x square minus expectation of x.
Yes.
Yeah. So in that case, like this is just a uniform distribution, right? So in this case, you can use the formula for the variance, which was like n square minus 1 by 12. Okay. And what is the expectation? Expectation is n plus 1 by 2.
Okay.
Okay. Right?
Right. Thank you.
Okay. Now the last is standard deviation. What is the standard deviation? It is just the square root of variance, right?
Just B minus A whole square by 12. No? Variance. Variance. B minus A
Variance
whole square by 12.
b minus a whole square.
By 12.
For what?
Variance of binomial distribution.
Binomial distribution. No, it is not the variance of binomial distribution.
Ma'am, in the previous case, you have directly given the formula, right, ma'am? Yeah, discrete.
So that is for uniform only. This is also a particular way in which you can present.
That's a, see, b minus a whole square by 12, it is for the continuous uniform distribution.
Yeah, continuous.
Okay.
This is discrete.
Huh? Yeah, this is discrete. Fine.
Yes, ma'am.
Yeah, and we had some properties like for the variance, like variance of ax would be equal to a square variance of x. If I have to calculate variance of ax plus b, it would be equal to a square variance of x. Okay. and variance of x plus y. This would be equal to variance of x plus variance of y when x and y are independent. Okay, these are the three properties you can say. Okay, this can be like for cave as well, like variance of summation of xi where I is going from 1 to n. This would be equal to summation of variance of xi when all the i's like xi's are independent of each other. Then only we would be having this formula. Okay, then we would be adding their respective variances. Okay. Is this thing clear?
Ma'am, can I know why in the first property square, hello,
Yeah.
v of ax equals to a square into v of x. Do we need to remember that?
Yeah, just remember this. It would be a square variance of x. Otherwise, you have to just variance of x, then you have to use that formula. It would be expectation of ax square minus expectation of ax whole square, like that. You have to, like, if you solve like this, then you will getting it to be as a square a square into variance of x only.
Okay, ma'am.
Yeah. Okay. So, and what is standard deviation? Standard deviation is the positive square root of the variance, right? And standard deviation is having the same unit as the random variable, right? Correct. And if I have to calculate the standard deviation of some constant multiplied by random variable, it would be equal to c into standard deviation of x, right? See, standard deviation of c into x, it would be square root of variance of cx, correct? Now, variance of cx is equal to c square variance of x. Square root of c square would be c, and square root of variance of x is standard deviation of x only.
Yes.
Correct. Similarly, standard deviation of x plus c would be equal to standard deviation of x only.
Yes.
Okay. So let's say if I'm if my variance is variance of x is 4, then what would be my standard deviation of 3x? So see, standard deviation of 3x, this is equal to cx only, right? So this can be equal to c into standard deviation of x.
Ma'am, it's 6.
So it would be 3 into 2, which is 6. Correct. Is this fine, everyone?
Yes, ma'am.
So if I'm taking variance of 2x plus 3, the value is 16. Then what is the value of standard deviation of x?
Eight? No.
8.
Ma'am, 2.
2. See, we have to calculate the standard deviation of x, right? So variance of 2x plus 3, I can write it as 2 square into variance of x, correct?
Yes.
Variance of x plus b is equal to a square into variance of x. Okay, so 2 square a is 2, so 2 square into variance of x, correct? And this value is equal to 16. So variance of x would be equal to 16 by 4, which is equals to 4 only. That means we got the value of variance of x as 4. So what will be my standard deviation of x? It would be square root of 4, which will be 2. Fine?
Yes, ma'am. Yes.
Everyone? Okay.
Yes.
So, okay. One more question. Like if I'm having I'm given a probability mass function, my x is taking values -1, 0, and 1. My probabilities associated with are 1/6, 1/2, 1/3. Okay. Now you have to calculate the expectation of 2x plus 1 whole square. Just calculate it and tell me. Is everyone calculating it?
Yes, ma'am. Just wait a minute.
Ma'am, here do we need to expand 2x plus 1 whole square?
Yeah, you can expand as well.
19.6, oh, 19/6. It's like 3.3.
6 something. Anyone else? You're coming out to be 19/6.
11/3 I got.
Yes, ma'am. I got 19/6.
Something must be wrong. Just check it. Who is getting 11/3?
Me, ma'am.
Yeah, that's correct. Anyone else? The answer is coming out to be 3.66 or 11/3. How many of you have, yeah,
3.6.
you're getting this value?
Ma'am, 3.66.
This is our answer. Has everyone solved this question? Has everyone solved this question?
Yes.
Or like other than her, like everyone, or do I have to solve it?
Yeah, please solve it.
I have to solve this?
Yes.
Okay, fine. So we have to calculate the expectation of 2x plus 1 whole square. So I'm just doing it by just opening the brackets. Okay. So this is one value, right? So I'm opening it. It would be 4x square plus 1 plus 4x, right? Now I can write it as 4 expectation of x square plus 1 plus 4 into expectation of x. Correct? Now, here the expectation of x is minus 1 by 6 plus 1 by 3. Correct?
Yes, ma'am.
Okay. So this would be equal to minus 1 plus 2 by 6. This is 1 by 6. Okay. Now expectation of x square, this would be equal to 1 by 6 plus 1 by 3. This would be 1 plus 2 by 6, which is 1 by, or we can say 3 by 6. Okay. Now, putting the value here, this would be 4 into 3 by 6 plus 1 plus 4 into 1 by 6. Okay. So if you solve this value, it would be
22 upon 6, I think.
got it?
Yes, thank you.
Yeah. Is it fine to everyone?
Yes, ma'am.
Is this in clear? Okay. Now there is
Yes.
one another question. X is taking values 0, 1, and 2. The probabilities is P, 1 minus 2P, and P. You have to calculate the variance. And tell me the answer. Okay? These are some of the previous year questions only. Somebody was asking, right? Is he here or?
Yeah,
Yes,
he's
ma'am.
there. He's there.
Okay. You have to calculate the variance. Then you have to calculate the expectation of 3x plus 2 as well. These are the three things you have to calculate. Okay, and tell me the
Variance
answer.
is equal to 2P.
Variance is
Uh,
2p. Okay. Anyone else?
Yeah, I got 2p, ma'am. Variance.
Okay,
Yeah, 2P.
good. I think the variance part, like everybody has solved the question. Now the second part, second question, solve it and tell me.
second part, I got 5.
Anyone else?
No.
Any other answers?
It's 5.
It's 5.
It's 5.
Okay, good.
Good.
Now the third question, third part.
Three by 4.
Anyone else?
Three by 4. Three by 4.
Good. So the answer is 3 by 4. So is it fine? Everything is clear? Everybody has solved the question,
one,
right?
last one
Yes.
can you solve?
Last?
Px less than 1.
I have to solve this. Do I need to solve this?
I think in third question you have to only find p of x is equal to 0 and p of x is equal to 1 and add the both.
Yeah, so that's what I'm asking. Somebody was asking something. So I'm asking him if I need to solve this. I can solve this if you want.
Yeah, please.
Okay. So probability of x less than 1, less than equal to 1. That means probability of x equals to 0 plus probability of x equals to 1. Correct?
Right.
This is the probability of x less than equal to 1. So it would be having the value 0 and 1. And probability of x equals to 0 is p. And probability of x equals to 1 is 1 minus 2p. Correct? Now, if I solve this, it would be getting it out to be 1 minus p. Right?
Okay.
Now it is given that p, the value of p is 1 by 4.
Yeah.
So 1 minus 1 by
Okay,
4.
okay, okay.
Is it fine now?
Ma'am, can you solve second one also? I'm getting
Second.
different answer. Yeah.
Okay. So let's first calculate the expectation. The values. So this would be equal to 0.
No, ma'am, actually I got correct answer. Yeah, sorry.
Okay. Okay. Then we have 10 minutes, right? Okay. Third question, we have been given a CDF. Okay. The CDF is 0, 1 by 8. So this is the CDF that we have been given. You have to calculate expectation of x square. First of all, what you will be calculating?
Probability mass.
Correct. You will be calculating the PMF, then you would be calculating the expectation. Good. Solve it.
Ma'am, can I know how to calculate PMF?
You just have to subtract it. Like this value 1 by like for probability, like x would be taking values 0, 1, 2,
3.
and 3, right? So for
Yes.
0, it would be 1 by 8. For 1, it would be, you would be subtracting it 1 by 2 minus 1 by 8. This would be 4 minus 1 by 8, which is 3 by 8. So this would be 3 by 8. Similarly, you have to calculate 2 and 3.
Yeah. Okay, ma'am. Thank you. Mom, why is it 1 by 2 minus 1 by 8?
Like here, when I
Is the answer 3?
yeah, the answer is 3. Everybody got the answer? See, in this case, when we calculated this was the PMF, the size. And how did we calculate the size? It was 3 by 4 minus 1 by 4.
Okay. So the same logic we're applying here as well.
Yeah.
Okay.
Yes, ma'am. 24 by 8 is equal to 3.
Yeah, 3 by 3.
I think it's a
Every
question of that head and tail, probably, because the probability looks same.
okay, this is our answer. Is it fine, everyone? Everyone were able to solve this question, right?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Now one last question. You have to make a PMF. Okay. So let's say a 6-sided die is marked 1 on 2 of its faces. Okay. Then 2 on 1 of its faces. Okay. It is a 6-sided die. 2 of the faces is marked 1. 1 of the faces is marked as 2. And 3 is marked on remaining 3 faces. Okay. The die is thrown twice. Okay. And X is a random variable which is denoting the total score in 2 throws. Okay. So you have to make a PMF of X. Is this question clear? You have a 6-sided die. Okay. 2 of the faces is having mark 1. 1 of the faces is having mark 2. 3 of the faces are having mark 3. Okay. It is thrown twice and X is denoting the total score in the 2 throws. Okay. So what would be my PMF?
Ma'am, here total number of outcomes are 36, right? No? Ma'am, can you give a clue, ma'am, to solve this question?
See, what are the values that X can take?
It's a
0,
2,
1,
3,
2,
4, 5, 6.
0, 1, and 2.
X can take 2, not 0. How 0 can take? The total score. It can
2,
take 2,
3,
3, 4,
4.
5, 6. It is,
Yes.
it has
Can't
been,
we take 1, ma'am?
how
No,
1
no.
can come?
Zero is
See,
not
X is the
on.
total score,
Yeah.
right? So we can have cases like 1, 1, 1, 2, 1, 3.
Yes, ma'am.
Correct? Like that. Similarly, we can have
2, 1, 2,
1,
2, and so on.
So, and this would be like we are having 6-sided, right? So for 6 faces, like 1, 1, then it would be 1, 1, 2 times, right? Then 1, 2, then 1, 1, 3, 3 times, right?
Yes, ma'am.
Similarly, we would be having 2, 1, 2, 1, 2, 2, 2, 3, 2, 3, 2, 3. So these were so like at last we would be having like similarly we would be having 3 at last, right?
Yes,
So
ma'am.
from 2, like we can't have total score as 1. Like the minimum is 2 and the maximum is 3, right? So it would be 2, 3, 4, 5, 6. So if I have to calculate the probabilities, like what the values of 2, it would be like from the 36 outcomes.
2 by
This
36.
But that is pretty much.
4. 4 it will be.
Yes, ma'am. I think 4 because one is
4.
different here.
Yeah. So 1 is different. Oh, okay. It is for the 1.
I'm sorry to bother actually. I didn't even now get total score means what.
When you're let's say when you're throwing a dice twice,
Yes,
okay,
ma'am.
one time, then 2 times, okay, you're tossing. So the number of points that to the total score, like when you are tossing, sorry, throwing the die once, you are getting 1 score, okay. So these are the score. Basically, 1, 2, and 3 are basically the scores.
Yeah,
Okay.
okay.
So when I throw it once, I'm getting one value. Okay, 1 score. When I'm tossing it twice, like second time, I'm getting the another score, right? So basically, the scores that we are getting on the upper side, we are actually adding it. That is the total score. Okay.
Okay, ma'am. Thank you, ma'am.
Yeah. So we will continue this question tomorrow, okay? Because it's like the time is up and you have a session, right?
Tomorrow you are taking, madam?
Tomorrow, no, I'm not taking tomorrow. It would be taken by someone,
Okay.
but
Please
yeah,
complete this and finish.
No
ma'am.
problem, no problem. We'll do it.
you would, okay.
Please explain this and finish.
Yeah, just try to solve it and tell me.
Yeah, the thing is what will be the value of x that we'll have to compute now for x is the total number of faces like that in both the throws.
Yeah, correct.
Just sum that. After summing, you put it in this function, then you have to multiply the probability of that.
Correct.
The
With
first
x.
probability for 2 will be 2 by 36, right?
No, it would be 4 by 36. See, here we are having this would be having 4 cases, right? Like the first die is having like 1 is for 2 places. Similarly, like for this we would be having like this is for the first die. So for first die 1 equals to 1, right? We would be having the second case as well.
Okay, then it will be 4, right?
Yeah, 4. Similarly, for 2, we are getting only 1, right? For 3, we would be having 3 cases, 3, 1, 3, 1, 3, 1, like that. Got my point? So in total, we are having 4. So it would be 4 by 36. Similarly, for 3, it would be 2 plus 1, 2. 1, 2, 3, 4. Similarly, we would be having same 4 by 36. Now you got it, how to calculate? Just make simple as that. You have to make just make a table here. 1, 1.
But look, 3 at the end, is it gonna be 9 by 36?
Where? See, just make a table here. So it would be 1 by 2, 1 by 3, 1 by 3, and 1 by 3. Okay. Now 1 comes 2 times, right? So it would be same repeat. We would be repeating it. So it would be 1 by 1, 1 by 2, 1 by 3, 1 by 3, 1 by 3. Correct? Similarly, now for the 2, it would be 2 by 1, 2, 1, 2, 2, 2, 3, 3, 2, 3. Now 3 comes 3 times. So it would be 3, 1, 3, 1, 3, 2. Similarly, 3, 1, 3, 1. It goes. Now third time. So in total, we have 36 cases, right? Now the sum should be 2. So what are the cases? 1, 2, 3, 4. So there are 4 cases in which we are getting the total score as 2, correct?
Yeah, fine.
Okay. Now for similarly for 3, it would be this, and this, correct?
Ma'am, in second row, last column, 1, 4 and 1, 3, ma'am. Easy.
Sorry,
1,
what?
3.
Yeah, okay.
Okay. Now I want the 4 as the sum. So it would be this one, this, correct? So there are total. These are the cases as well. This one. Okay. So in total, we have 13 out of 36 cases in which the sum is 4. Got it? Now the sum 5, which is 2, 3. Okay. Then this one. Similarly, we would be having here as well. Right? So it would be coming out to be 1, 2, 3, 4, 5, 6. So it is 6 by 36. Similarly, you have to calculate for the 6. It would be 4 cases, which is 3, 3, 3. Not the 4 cases, it would be 3, 3, 3, 4, 6, 7, 8,
9.
9. 9 cases, which is 1 by. Now is it fine? So this is the PMF of the X random variable. Everybody understood?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So, yeah, this was from the previous year question only. So yeah, this was all.
Okay, ma'am. Thank you.
Yeah.
Okay, thank you.
So the doubt is clear to everyone from
Yes,
week 9
ma'am.
and 10?
Yes, ma'am.
Okay.
Okay.
Fine. Okay. All the best for the exam to
Thank you,
everyone.
ma'am.
Okay.
Thank you.
Thank you.
Thank you, ma'am.
Hello, ma'am.
Hello.
Ma'am, where do we find this PDF?
Which PDF?
This all lectures PDF.
The today's,
And all others previous session also, ma'am.
it would be in the supplementary content only.
Where, ma'am? I cannot find it.
Let me see. Just a second. I think they haven't uploaded it yet. Just a second. Let me check. Okay. Okay, we will upload it. Fine. Yeah. Like tomorrow or day after tomorrow, it will be uploaded.
Ma'am, but exactly where is the location of in which it will be
It would
uploaded?
be in supplementary content only.
Ma'am, I could not find it.
No,
In
we haven't
supplementary
uploaded. We haven't uploaded it yet. So
previous lectures PDF is also not uploaded.
Okay, we will let you know about this. Okay.
Ma'am, why don't we just upload it in the calendar?
What? The PDF?
Yes.
Um, I think let me see to it. Where can we upload it? Let me see. Okay.
Okay, ma'am.
Yeah. Okay. So can we end this meet?